So up to now we have seen what is a map, three different data structures involved in map like hash map, linked hash map, tree map. We have seen all of those, and we have seen the implementation and the operations involved in it. Now we're gonna start the second part of hashing concept, that is set. So we have already listened the name set in math. When we are studying set 3, we have listened the name set, right? So a set is a collection of elements. Set is a collection of, I can say, unique elements. We can't create replica of elements, right? And let's say this is a set and I can store 1 2 3 4 and we will have a null element, right? Like this we define a particular set in mathematics. So to replicate this mathematical process in computer science, to replicate this thing, we use the concept of set. And again, so in sets we have three different data structures: hash set, linked hash set, and tree set. And one more thing you need to remember is that maps and sets are very similar to one another. The only difference between a map and a set is that in map we use key value pair to store data, whereas in a set we don't use any key value pair, we just store directly the key, that's all. So a hash map is very similar to hash set. The time complexity, the operations, whatever the operations which we were doing in a hash map, we will use the same operation, we will use the same methodology to perform operation, and the time complexity, the order wise complexity also will remain the same. So I can write here that hash map is equivalent to hash set and linked hash map is equivalent to linked hash set, and tree map is equivalent to tree set. And not just the operations we perform, the internal implementation is also same. This hash map is implemented on arrays of linked list, and here we use single linked list. Similarly, linked hash set is also implemented in arrays of linked list, but we use doubly linked list there. And tree set is implemented using the concept of red black trees, right? So the implementation, the operation, and the time complexity of these three data structures, the maps, these three data structures of maps and the three data structures of sets is very same to one another, right? But the only difference you need to remember between a map and a set is that in map we use key value pair to store data, whereas in set we don't use any key value pair, we just add the elements in it, that's all. Now let us start with our first thing, the first type of set, that is hash set. Hash set has three properties which you need to remember. That is, we can't add duplicate elements in my hash set. Let's say I'm adding 1 3 times. So internally what happens is that my hash set won't consider 1 3 times. It will only add only one time. After it won't add any further elements which are repeating. Like this we can't create duplicates elements in my hash set. And the second property is, I have said you that hash map and hash set are very similar to one another. If you recall the properties of hash set, in hash set it is unordered, it is not in a structured format. Similarly, hash set is also unordered, and whatever the elements you are adding, it doesn't have to be come out in the same way, it will come out randomly. Let's say I am adding 1 2 3, and if I print the set, then I will get some random elements like 2 3 1. It doesn't have to be in an order. And the third is null is also allowed. Null is nothing but you can say an empty element. In sets we have elements right here, you can see 1 is element, 2 is element, 3 is element, 4 is element, and along with this valid elements I have a null element. In set 3 I have a null element and we represent it 5. So to represent that also we use the concept of null here. So in hash set no duplicates are allowed, it is in unordered fashion, and it will have a null. So this is about hash set. Now what is the visualization of hash set? We will visualize a hash map. Like this. Here we will have key, here we will have value, and we will store it. Now to visualize, we visualize a hash set something like this. You can say in a form of a set. This is how we represent a set in a Venn diagram, right? So in the form of a set we represent hash set. Now let's say that here I'm adding 1 2 1 2, 3. Now first of all, what will happen is that 1 will get added in the hash set and 1 will become an element of my hash set. After that, it will iterate through the second element and it will check whether 2 is present in my hash set or not. If it is not present, then I will add it. Now I will add it. After that, I will go to 1. 1 is already there and I can't create duplicates, so I will iterate through the next element, and 2 is already there, I can't create duplicates, so I will move to the last element. After that, I will add 3. Like this, we will visualize a particular hash set in my given program. Right now, let us talk about how we can create hash set in my program and what are the operations that goes in it. So first of all, to implement a hash set in my program, I will write hash set and I will write the key data type. Whatever the data type of hash set I want to create, let's say I want to create character set, so I will write character here. If I want to store numbers, then I will write integers. If I want to store some boolean value, then I will write boolean, right? If I want to store true or false, I will write here boolean. In the place of integer, I will write boolean. So first of all, hash set, angular brackets, in that I will give the data type which I want to create. After it, my hash set name is equals to new hash set. Like this, I will create hash set in my Java program. Now the operations I said, we perform the same operations with the same time complexity. Let's say if I want to add elements, then I will write hs.add and I will write big of it. If I want to check whether this particular key exists in my hash map or not, then I will write contains. If I want to remove a particular element, then I will write remove. Like this, I will perform operations in my hash set. I hope you have understood the overall, like what is the concept of hash set. Now let us code this thing. So I have imported import java.util.star. After it, I have created my class, my hash map. After it, in the main program, I am creating my hash set. So I will write hash set, and let's say I am creating integer hash set. So I will write integer and hs is equals to new hash set. Like this, I will create my hash set. Now if I want to add elements, then I will write hs dot add, and let's say I'm adding 1. After it, hs dot add, and I want to add 2. After it, hs dot add, let's say I'm adding 3. Like this, I'm adding elements. Now if I want to print my hash set, then I will write system.out.print and I will write hs. Now if I run this output, I know that the operations, the insertion happens in an unordered fashion. In an unordered fashion, insertion will happen, right? So if I want to print, then I will get the elements in a random fashion. So let me save this and run. So you can see that I got the output in the correct fashion. Now if I want to add a new element, then hs.add, let's say I'm adding like 0, and save and run. You can see that I got the elements in a unstructured format. You can see that I have inserted 0 at last, but in the output screen I am getting 0 at first. Like this, the insertion happens in a unstructured format. Okay. Now let us talk about how we can iterate through the elements of my hash set. I have created a hash set. Now I want to run a loop in this hash set. So if you recall the properties of iteration properties of hash map, I will use a for each loop in that. In that I have used for each loop. Now to iterate in a particular hash map, to iterate through each and every index, through each and every element in my hash set, I will use two methodologies. The first method is general method, that is using iterator. Now one more thing you need to remember is that let's say I have an array. Now I want to iterate through each and every index of this array. Then what I will do, I will create a loop for int I is equals to 0 and I will iterate through each and every index, because you know that general loop is for primitive data type. You know, whenever I want to iterate through a set of items which are having primitive data type, then I will use that. Now here you need to understand that hash set is little bit different from general looping system. So to perform a general loop in my hash set, I need to create a object of a class called as iterator. So I will write iterator and I will write I is equals to set.iterator. So this function will create a iterator. After it I will write while, let's say I am having a set s is equals to 1 2 3. So while I dot has next, then what I will do is that if I has a next element, then I will come in my loop and after it I will write system.out.print and I will write whatever the key value I'm having, right? I dot next. Like this, I will print the elements in my hash map, hash set. Okay, so let's set here, these are the elements. So initially I will create a pointer, and this is how I will create a variable. I will create a iterator. I can't use a normal loop for my hash set because this is different from general elements. Okay, so what will happen is that first of all I will create a iterator, this pointer, and this pointer will initially points to null. After that, what are the elements I am having? 1 2 3. So initially this pointer will points to null. Okay, now after that I will check while I has next. You can see that I has next element. So if it has a next element, then I will move to next pointer and I will print that element. So in my output screen, my output will be, first of all I will print 1, after that I will move to 2, after that I will print 2, after that I will move to 3, I will print 3. Now you can see that after 3 I don't have any elements. If I don't have any elements, then I will stop my loop. Like this I will iterate by using this general method. I will iterate. The second method will be using a enhanced loop. This enhanced loop is nothing but for each loop. So I will write for integer, I will write integer class I in my set yes. I will write system.out.print, I will print I. Like this I will use for each loop, or I can use a general iterative interface. So by using this iterative interface, I can iterate through the elements of my set. This is method 1. In order to iterate the elements in my set, I use this method 1, or I can use for each loop. Now most of the times, if I say like in real time which loop we use, we most of the times for sets, for maps, we use enhanced loop, that is my for each loop. Okay, now let us see how we can code this. So here let me remove this. Now first of all I will create an iterator. Iterator I is equals to hs dot iterator. Now for what I will do is that I will iterate while I dot has next. If it has next, then I will print system.out.print I dot next. Like this I will print. Now if I run this code, then I will get the output. Whatever the elements I have inserted, I should get in the output screen I should get the elements. Now let me save and run this. So you can see that I got the output as 0 1 2 3. Like this I will print. This is my iterative method 1. This is method 1. Now if I want to use the other method, then what I will do is that, let me delete this. This is my method 2. I am writing my method 2, that is nothing but for each loop. So I will write for each, and I will write integer, and let's say here I am giving I. Then in this I will print system.out.print, I will write I. Like this I will iterate. This is my method 2. Now if I run this code, then I will get the same output. Now let me save. Here let me give j because I am using the same variable, right? So let me give j here. Now let me save and run. So if I run the code, then I will get the same output. You can see that I'm getting 0 1 2 3, after that again 0 1 2 3. So these are the two different methods that we use in order to iterate the elements in my hash map. These are the two methods. First one is I will create iterator interface. Iterator I is equals to my set name dot iterator. Right, after that I will run a while loop. In the while loop I will print the elements. Like this I can use my method 1. If I don't want to create an interface of iterator class, then I can simply use my for each loop and I can print the elements present in my hash set using for each loop. Now let us talk about other data structures. Talking about linked set, the difference between a linked hash set and a normal hash set is that if you recall the properties, you can see that the property, one of the properties, it is in unordered fashion, and we have seen that at last I added 0, right? And if I run when I run the output, I got the output 0 on the top. So the adding operation is taking place randomly. So in order to avoid this random insertion in my hash map, I use linked hash map. And what is the internal difference between a hash set and a linked hash set is that internally it will also use the implementation of arrays of linked list, but in the place of single linked list we use double linked list. And because of this double linked list, my insertion happens in a structured format. Let's say I'm adding 0 -1 -2. So in the output screen I will get 0 -1 -2. Like this in a structured format my insertion will happen. And how I can create my linked hash map? First of all I will write linked HashSet, and I will write the data type. After that my name HS is equals to new linked hash map, and the operations is same, right? We are using the whatever the operations we are using in the HashSet, we will use the same operations here also. Now let us talk about another data structure, that is TreeSet. I will show you the code of linked HashSet and a TreeSet in a combined fashion. So a TreeSet, what is the difference between a HashSet, linked HashSet, and a TreeSet is that whatever the keys, let's say I'm adding 1, after that 10, after that 0, after that -1. So in this fashion I'm adding elements in my TreeSet. Now if I print the output, then in the output screen I will get the keys in a sorted fashion. It means that first of all I will get -1, after that 0, after that 1, after that 10. In this order, in this sorted fashion, I will get my output if I have created TreeSet, right? This is the one of the property of TreeSet, and internally the implementation happens by using a concept called as red black tree. So we use the concept of red black tree here, and red black tree I have told you that it is very similar to AVL trees. By just reading the material you can understand it, that AVL trees and red black trees are basically same, but here we use the process of coloring, that's all. Now the second property is null is not allowed. You need to remember that in linked HashSet null is allowed, right? And in TreeSet we don't allow null. It means that we can't have a null element. Okay, so I will give a brief recall about HashSet. So HashSet is a set in which no duplicates are allowed, unordered, and null is included. But here in linked HashSet no duplicates are allowed. Here also no duplicates are allowed, but this is ordered, and here also null is allowed. And in TreeSet the property are, it is in this also no duplicates are allowed, and the output will be in sorted fashion. The keys are inserted in sorted fashion. After that null is not allowed here. This is the only basic difference between the same. And time complexity of TreeSet is slightly higher than linked HashSet and HashSet. Okay, so the time complexity, I think it is around big of log n. Like this we will study the different sets. So we have completed 3 different sets. Now we haven't coded the linked HashSet TreeSet. Now let us code this thing. So here let me remove the iterative step, and first of all I will create my linked HashSet. So linked HashSet, and I am creating integer type. So I will write integer linked HashSet is equals to new linked HashSet. Now let's say that I am adding the same elements. So I am adding the same elements here, and here in the place of HS I will give L here. So I will give L and L. Now after that I am printing my output. So system.out.print, let's say I am printing LHS. So if I run the output, then I know that the insertion happens in an ordered fashion. So let me save and let's see the output. So you can see that I got the output in a structured format. So the element which is going in will coming out, will coming in the same fashion in the output screen, right? This is how the insertion will happen in linked HashSet, and the operations are same. The operations will remain the same, right? I can perform add operation, remove operation, contains, all the operations will remain the same. Now let us talk about TreeSet. I will write TreeSet and I will write the data type. Let's say I am creating integer, so I will write integer ts is equals to new TreeSet. Now if I wanna add elements, then let's say here I am giving in the place of here, let me copy this and add the same. Now in the place of ts, let me give the TreeSet here. Okay, now after this let me copy this thing also and here let me print the tree set. So what is the property of tree set? Tree set says that whatever the elements you are inserting, you will get that in a sorted fashion. So if I run this, then I will get 0, after it 1, after it 2, after it 3, like this insertion will happen. Now let me save and run this. So you can see that I got the output. First of all, let me comment this thing out. Okay, now again save and run. So you can see that I got the output. First of all, I got 0, after 1, after 2, after 3. So in this sorted fashion, I will get the output in my tree set. So this is the basic difference between a hash set, linked hash set, and tree set. I hope you have understood. Now up to now we have completed all the operations, concepts of maps, and we have completed all the operations of sets. Now let us do some questions. After it, we'll complete the chapter. So here let us talk about a question. Here the name of the question is count distinct elements. In the question, user will give us an array and we need to tell how many unique elements are there. We don't count count the replica, we don't count duplicates, we only count element only once at a time, right? Only one at a time. So here you can see that 4 is repeating 2 times, but I don't consider 4 2 times. I will count the occurrence of 4 as 1, and I need to tell how many unique elements are there in my given tree, in my given array. So here you can see that 4 has repeated 2 times, after 3 has repeated 1 2, 3 has repeated 2 times, after 2 has repeated also 2 times. So 2 has repeated 2 times, 5 has repeated 1 times, 6 has repeated 1 time, 7 has repeated 1 time. After 4 we have counted 2, we have counted 1 has repeated 1 time. Now we don't consider this repeating, we only consider how many unique elements are there. How many unique elements are there? 1 2 3 4 5 6 7. So the unique elements present in the given array are 7, and my answer would be 7. Now let us talk about the approach. I hope you have understood the overall asking of the question. In the given array, the elements are repeating, but I don't consider that repeating elements. I only consider element only one at a time, and I need to tell how many unique distinct elements are there in my array. So to calculate that, let us talk about brute force. So in brute force, what we will do, we will create a new array. We will create a new array and we will add the occurrence of each character by creating a minimum maximum element. We will create a new array and the size of array will become maximum element minus minimum element, and we will take the occurrence of each character and we will run some loop, and that will take around, if you go with brute force, the time complexity will take around big of n square. Okay, now what we're gonna do is we are gonna use the concept of set. So in sets we know that duplicates are not allowed. Duplicates are not allowed in set. So what I will do is that I will create a hash set and I will run a loop. Second step will be run a loop in my num array, and as you run, add the elements in your hash set. So what I will do is that, let's say this is my hash set. Okay, so I will iterate through each and every element. So I will come to 4, I will add 4 in my hash set. After that I will come to 3, I will add 3. Now after that I will come to 2, I will add 2. After that I will come to 5, I will add 5. Similarly 6, add 6 in your hash set. This is my hash set, right? After that I will come to 7, I will add 7. Now I will come to 3. 3 is already present in my hash set and I know that I can't create duplicates, so I will iterate to the next element. 4 is already present, 2 is already present, 1 is not present, so I will add 1. Now the third step will be I need to tell how many unique elements. So how many unique elements are there? When I dry run, I got the answer 7, right? So count the size of the hash set you have created. So count the size of it. So if you count, you can see that 1 2 3 4 5 6 7. So what I will do is that I will basically print hash set size. That's all. So what I did, first of all, I have created hash set, and the second thing is I have run a loop for n elements. Let's say there are n elements in the worst case, so I am running loop for n elements and I am including that element into my hash set. Okay, and I know the property of hash set, that is no duplicates are allowed. Okay, so if no duplicates are allowed, then all the elements will be unique. Okay, so the third step will be finally print the size of that particular hash set, right? So for this, the time complexity will be big of n. This is how we use the concepts of sets. Whenever you, like here, the word frequency in a question, I'm telling you this is as a tip, that when you hear the word frequency, it is related to 80 to 90%, the probability is that that question is related to maps. If you are having some key value pair, then you should do that question using the concepts of maps. If you are occurring the count, distinct and union, intersection, concepts related to math and specifically related to set theory, then you should use the concepts of set. Now I hope you have understood the approach. Now let us code this thing. So I have taken in the program I have taken the example which we have dry run. Now what is the first step? Step 1 is create hash set. So step 1 is create hash set. So I will write hash set, and here I will write integer because I am storing integer. HS is equal to new hash set. Now after creating hash set, step 2 is run a loop. So I will run a loop for int I is equal to 0 and I should be less than arr dot length. After that I plus plus. Now in this what I will do is that I will add elements into my hash set. So hs dot add arr of I. Now step 3 is basically print your hash set size. So whatever the hash set you are having, print its size. So system dot out dot print, and let me write here the distinct elements in array is, and let me give a space here, and I will print hs dot size. Like this I will print elements in my hash set, right? Now let me save this thing and run. If I run this code, then I should get my output. So you can see that I got the output as the distinct elements present in my array is 7, and I have dry run the question and I have showed you that what is the answer is 7, and I got the same answer. Like this, without running n loops, without running 2 loops, without worrying about brute force approach, if we know the concept of set, we can easily implement this kind of questions. Now let us talk about another question, and the name of the question is union and intersection of two arrays. So user will give me two array arr1, let's say this is array 1 and this is array 2, and in array 1 I will have some elements, in array 2 I will have some elements. Now I need to tell how many elements will be there when I perform union operation, how many number of elements would be there if I perform intersection operation. So you need to recall the union and intersection process. So union, let's say that here I am having a set A and the number of elements are A, B, C, and I am having another set, let's say the elements are X, Y, Z. Now if I perform a union operation A union B, then my set would be whatever the elements in the A and B, I will combine both of them and I will remove the duplicates, right? So my output will be A, B, C, after that X, Y, Z. Like this I will perform union element. So a union, if I show you in the form of Venn diagram, let's say this is A, this is B, then the union will be this, right? This will be my union. And intersection would be, let's say this is A and this is B, whatever the common elements which we are having in between them, then that particular thing will become my intersection of A and B. This is the mathematical concept beyond union and intersection. Now the user will give me two arrays and I need to tell that how many union elements are there. When I perform union operation, how many elements would be there. When I perform intersection operation, how many elements would be there, I need to tell my user. So how we can do this question? First of all, let us talk about union. So talking about union, first of all I will use, whenever I see a union, intersection, distinct elements, unique elements, I will try to apply the concepts of sets. And whenever I come across frequency, count, key value pair, countries, population, if I come across this sort of things, then I will use hash map, right? So what I will do is that talking about union approach, first of all I will create a hash map. The first thing would be I will create a hash set. Now the second thing will be I will run a loop for arr1, and I will add arr1 elements in my hash set. Similarly, I will run another loop for arr2 elements, and I will add arr2 elements in my hash set, because I know that I can't create duplicates. Now the third step will be I will print the size of the given hash set, that's all. So what will happen is that, let's say this is my hash set. So for union, what I'm doing is I'm iterating through each and every element. So union is nothing but combination, whatever the elements you are having in set A, set B, combine those two and remove the duplicates, right? If duplicates are forming, remove them, and whatever the elements you are getting, you are left, that is your union. So what I will do is that I will iterate through first of all each and every element of array 1 and I will add that particular element in my hash set. So I will add 7, after that I will add 3, after that I will add 9. I will iterate through each and every element. Now after that I will come here on my array 2. Now I will see whether 6 is present in my hash map or not. If it is not present, then add it. After that I will come to 3. 3 is already present, so I don't need to add it again. After that I will come to 9. 9 is already present, so no need to add. After that come to 2. 2 is already present, so 2 is not present, so 2, add 2 in your hash set. After that come to 9, 9 is present. After that come to 4, 4 is not present, so 4. So how many elements are there? 1, 2, 3, 4, 5, 6. So the output of union will be 6. This is the approach of union. I hope you have understood. So what I did is that I have used the properties of hash map. First of all, I have created hash map, run a loop for array 1, add that elements in your hash set. After that run a loop for array 2, add the array 2 elements in your hash set. After that finally print the size of your hash set. This is the simple approach of finding union. Now talking about intersection is an interesting process. So in intersection, what I will do is that, let me remove the ink here. Okay, so talking about intersection, what I will do is that first of all I will create a hash set. First step will be create hash set. After creating hash set, second is run a loop for array 1 and I will add the array 1 elements in my hash set. I will add these elements into my hash set. So first of all I will add 7, after that I will add 3, after that I will add 9. Okay, this is how I will add. Now third step will be I will create a count variable, count is equals to 0, and again I will run a loop for array 2. For array 2, now I won't add the array 2 elements in my hash map. What I will do is that I will check whether this particular element is present in my hash set or not. If it is present, then it is a common element. If it is not present, then it is not a common element. So I will check whether this particular element is present in my hash map or not. If it exists, if this particular element already exists, then I will increment the count value. If it doesn't exist, then I will continue to my next element. Like this I will run my loop. So what happens is that first of all I will come to 6. I will see whether 6 is present in my hash set. No, then continue to the next element. Now I will come to 3. 3 is present in my hash map. So hash set, so count will become 1. After that I will come to 2. 9 element is already present in my hash map, so I will increment the count value by 1, so the count will become 2. After that I will come to 9. 9 is not present, so continue, and after that you can see that I have already counted 9 one time, and I know that I can't create replica element, so I will ignore it. Now after that I will come to the last element. 4 is not present, so what is the count value? Count value is 2, and that is my intersection value. Like this I will calculate the intersection, and for union I am running a loop 2 times, 2 separate loops, so the time complexity will become big of n plus m, that is nothing but big of n. Okay, and for intersection also I am running 2 different loops, but these are not nested loops, so the time complexity for insertion will also big of n plus n, and that will give me a linear time also, right? Now let us code this thing. So in the main program I have created 2 arrays and I have taken the example which we dry run. Now what is the step 1 for union? I'm gonna find union. So for union the step 1 is create your hash set. So I will create hash set and I will write integer because I'm giving the count, right? I'm adding the element. So integer hs is equals to new hash set. Why it is showing some kind of error? New hash set, right? After creating hash set, I will run a loop for int I is equals to 0 and I should be less than arr1 dot length I plus plus, and I will add this arr1 elements into my hash set. So hs dot add arr1 of I. So I am adding the elements. Now after adding elements, I will run my second loop for the next array. So for int I is equals to 0 and I should be less than arr2 dot length after I plus plus. In this, what I will do is that I will add hs.add and I will write arr2 of I, arr2 of I, and after this what I will do is that I will basically print system.out.print and I will write hs, the size, the union elements, the number of union elements are, and I will print the size, how many elements are there present in my union, I will print it. So I will write here hs dot size. Now after performing union, after that I need to calculate the intersection also. So what I will do is that I will clear my hash map. Whatever the elements I am having, I will remove all of those. So I will write hs dot clear, clearing my hash map. Now I will go to intersection. So intersection, talking about intersection, the step 1 is run a loop for the first array. So yeah, for I is equals to 0 and I should be less than arr1 dot length. After that, increment I plus plus. Now in this, what I will do is that I will add arr1 element into my hash set. So hs dot add and arr of I will add it. Now after adding the element arr1 of I, after adding the element, I need to check whether this particular element in my hash set is present in my array 2 or not. If it is not present, then I will continue. If it is present, then I will increment the count value. So int count, I will create a count. So int count is equals to 0, and after that I will run a loop for int I is equals to 0 and I should be less than arr2 dot length, and after that I will increment I plus plus. In this, what I will do is that I will iterate through each and every element of array 2 and I will check whether this particular element is present or not. So if hs dot contains this particular element arr2 of I, if this is true, then I will increment the count value, else I will continue, right? After iterating, after performing all the loops, I will print system.out.print number of elements in intersection are, and give a space and plus I will just print the count value. Like this, I am performing my union operation after intersection operation. Now let me save the code and run this. So you can see that I got the output as the number of elements in union are 6. Total number of elements are 6. After the number of elements in intersection are 2. Like this, we will calculate how many elements present in intersection and union. So up to now we have seen what is hashing. In hashing, using the concepts of hashing, we derive 2 data structures. First one is hash map and second one is first one is map, and after the second one is sed. In map we have again 3 different data structures: hash map, linked hash map, after the tree map. In set again we have 3 different data structures, that is hash set, linked hash set, after tree set. And we have seen the implementation, how the operations will go on, the time complexity of these different things, and we have solved some questions based on the concept of maps, and we have solved some questions on the based on the concept of map set. So up to now we have covered all the things related to hashing. So with that being said, I will see you in the next chapter. In the next chapter we'll talk about some new concepts and some interesting concepts. So with that being said, I will see you in the next one.